I really need to finish this essay. What the heck? What happened to my computer? Oh no, I think I just lost all of my work. Oh no!
We are heavily dependent on electricity. It seems like we can't function without it. We take electricity for granted and assume that it will always be there when we need it, but as we know, that's not always true. Our electric utilities do a great job of providing reliable service, but with aging infrastructure, natural disasters, and the potential for cyber attacks, we still have to deal with short-term interruptions and disruption to our everyday lives when the power goes out. In our homes, this can be anything from an annoyance to a life-threatening event for those who require electricity for medical devices. In government operations and our businesses, with today's sensitive electronic loads, power disruption brings work to a halt, impacting employees and customers.
In many cases, electrical users have purchased extensive backup solutions like batteries, generators, and uninterruptible power supplies to minimize the impact of an outage. In addition, with the ever-increasing cost of electricity, some end users have elected to add their own power sources, including renewables like solar and wind. With limited dollars and limited technical resources to optimize all of these interdependent pieces, consumers of electricity are often stuck with expensive and sometimes less reliable systems. So what's the answer?
Well, what if the smartest grid of all was your own microgrid? Here at the Power System Experience Center, we rely upon a full-scale operational microgrid to minimize disruptions and intelligently use multiple sources of energy. Let's take a look.
So what is a microgrid? Microgrids are standalone electrical systems consisting of multiple generating sources and defined loads that can operate either connected to or independent of the primary utility grid. They provide a reliable, efficient solution to unexpected power loss, effectively balancing variations in energy demand, optimizing energy usage for more reliable power, reducing operating costs and carbon emissions. Why would you install a microgrid? The key drivers for installing a microgrid are essentially reliability and cost. Let's look a little more into the details of why. First, resiliency is a key driver. For example, the microgrid can restore power following a natural disaster like a hurricane or the failure of a major component on the utility. With the aging infrastructure of the power grid, this is becoming more of an issue every day. Secondly, with the high penetration of renewable generation in some areas, these sources have contributed to the instability as utility-based generation is retired or taken offline. As you know, the sun sets, clouds pass by, and the wind stops blowing. Large step changes make the source and load incompatibility a huge shock to the system and create significant instabilities in the electrical grid. Finally, a microgrid can allow users to control electrical demand and minimize cost of energy by optimizing available sources like natural gas generators or batteries, while integrating load shedding schemes as necessary. Eaton has significant experience in all of these areas, and to that end, we've built the microgrid here at the PSEC to show you how microgrids work.
The PSEC microgrid is a 50 kilowatt fully operational system consisting of 4 sources, including utility power, a generator, solar power, and energy storage in the form of batteries. These sources supply continuous and optimized power to the building loads, including 4 large controllable HVAC units, lighting, and plug loads. This allows us to fully demonstrate the key functions of reliability and cost savings for our microgrid. This graphic, for example, shows how we utilize solar when it is available to supplement or replace the utility source during the day, and charge our lithium-ion batteries if we have more solar energy than required by our loads. In another example, we can charge the batteries when the power is less expensive overnight and utilize this lower cost energy for loads during the day. All of these functions are controlled by Eaton's Power Expert Energy Optimizer controller which is the brains of the operation. The Power Expert Energy Optimizer controller utilizes a two-level control architecture. Local controllers interface with each source, and a system controller coordinates all microgrid operation and provides additional intelligence. This architecture is designed to be scalable to large distributed microgrids, such as military bases, campuses, or utility feeders. So, what you see at the PSEC is Eaton's full microgrid control system, simply scaled for PSEC building loads. This MCC is the common bus for accumulating all of the microgrid sources and loads. In a much larger system, this would typically be low voltage or medium voltage switchgear. Recall that a primary driver for microgrid is resiliency. That is the ability to continue powering loads in the event of a utility disruption. When the microgrid is operating independent of external sources, we say the microgrid is islanded. For certain utility disturbances, or when islanding is initiated manually, it is possible to transition from grid-connected to islanded states with no power disruption, referred to as seamless islanding. This process includes adjusting the output of the energy storage and the generator to match the load, shedding some microgrid load if necessary, then disconnecting from the utility. In some cases, severe disturbances can result in complete loss of power. Some microgrids are capable of independently restoring voltage to the loads. This is called a black start. At the PSEC, our microgrid can utilize either energy storage batteries or the natural gas generator to restore power. This occurs automatically, and the source is selected based upon user-defined priorities. In fact, this provides two levels of redundancy. If one alternate source is not available, for example, if the batteries are discharged, the next source, or the generator, is automatically selected. While in an islanded state, the microgrid maximizes the use of free solar energy. Any excess energy is stored in the batteries. If the generator is running, it also supplies loads and charges batteries, allowing the generator to be turned off for intervals while the batteries carry the load. Once the power returns and stabilizes, the microgrid will automatically match the voltage and frequency of the utility. Once the voltage and frequency are matched, the utility breaker closes and the microgrid returns to normal on-grid operation. This is a closed transition with no disruption of power.
Often, resiliency alone does not provide sufficient economic justification for a microgrid. The good news is, a microgrid can provide other benefits. With the addition of energy storage to a microgrid, energy from intermittent sources such as renewables can be moderated, and other sources of energy can be used intelligently based on cost, emissions, or other targets. We often make the comparison that a battery in a microgrid system is like a pump storage system. A pump storage system has two lakes, one at the top of the hill and one at the bottom. During the day, water is released from the top lake and electricity is generated with a hydro generator. Electricity is sold for maybe 12 cents per kilowatt hour. At night, guess what they do with the water? They pump it back up the hill from the bottom lake to the top lake. You're probably thinking, why would you do this? It's because they can sell electricity for 12 cents, but buy it overnight for 3 cents. So even with the losses, they're ahead of the game. It's the same as this battery system. We fill it up when power is readily available from the solar source, or overnight when energy is cheap, and discharge it to stabilize the load and minimize our demand from the utility. Integrating renewables and optimizing cost allow the microgrid to offer significant financial rewards.
With the sophistication of Eaton's Power Expert Energy Optimizer controller, microgrids can do more than just recover from utility outages or integrate renewables. The options are almost limitless to make your system work the way you want. Some additional features include power factor correction, voltage regulation, demand response, and frequency regulation or active power dispatch for specific utility markets. Eaton's microgrid capabilities include feasibility studies, modeling, simulation, engineering, and design services with existing or new sources. We also offer project management and turnkey installation of your microgrid and related power system. In addition, our control platform and architecture integrates security features and practices to minimize your cybersecurity risk.
Microgrids in various forms have been around for decades, but in recent years, many factors have converged that make microgrids increasingly viable and urgently necessary. No two microgrids are identical. Eaton has significant expertise in designing, controlling, and installing microgrid systems. We can put the power in your hands to optimize your power system.
Here at Eaton's Power Systems Experience Center, you can see a real microgrid in action and discuss your needs with our engineers to see if a microgrid is right for your power system.
Contact us or your local Eaton representative to schedule a visit to the Power Systems Experience Center today.